All right. So.
Oh yeah, he did say that you knew them though. I was like, so you picked the poop, right? And I was like,
Oh
so
my
everyone,
God,
no.
bro.
Everyone that picked it, I said, well, what if someone pooped it out right in front of you? Would you still do it? And Pal was like, yeah, I wouldn't even need a break. he said, ask him that.
All right,
Okay.
today's lesson.
Awesome. All right, so we are integrating this from L over 2 to negative L over 2. Okay, so yeah, right. So you got to use U substitution, maybe.
That's a no. It's my
You have 3
yes,
seconds
I
to say
still
yes.
doubt it.
All right.
Never know.
All right, so
The slides are on Canvas.
they are on Canvas. All right, so we pull out all this. This is all constant. Okay, the only thing left is this stuff.
Y is technically a constant.
It is, but I think we're going to use it for integration. So you get use substitution to get that, and saying that yeah, use substitution, and then we plug in our values, and so we end up with this. Okay, and that's at the midpoint. This is specific for the midpoint of a uniform rod with length L. This equation. It has potential to be on mastering, yes.
Are we gonna have to like do this like on the test? Like you stuff?
Sometimes.
But we didn't have our TI-89, right?
Sure.
Yes. They're gonna ban them.
They haven't yet. They've been in existence for a long time. Okay.
I would fail the exam if my calculator were banned.
There we go with that. All right, so here's the equation. What happens if it's really far away compared to the length?
Just approach this.
Correct answer is C. Okay.
You don't want to make y go to infinity.
You don't. Yeah, you make L go to 0, and essentially just becomes a point charge. Good with that? Okay. All right. So find the electric potential at the dot of a uniformly charged rod, length L, charge Q. Yep.
Live from Harrison High School.
So here's the general equation for a point charge for electric potential. Okay, that's of a point charge. So go ahead and give that a shot. Find electric potential. Recognize electric potential is not a vector. Go. give you like checkpoints along the way. So I want to integrate this from and I want small chunks of that. I want a small chunk of charge a certain distance away.
What is D? Oh.
You're good. You're good. You're good. A little chunk of charge.
I thought you should use DX.
I'm just giving you checkpoints. If you're stumped, my hope is that you beat me to the answer.
I got the integral, I just didn't bother simplifying it in my head. And bounce integration.
And let's say let u is equal to. You guys might be able to do this in your head, but I'm rusty on it. So du over dx. So
Y
dx.
is a constant.
Yep. Y. So x is equal to. Oh, that's not helpful.
You have to do trig sum.
Have to do what, sub?
Trig sum.
Oh, I know what that is. I think it is. Oh, it's a wire. That is a thing.
A little rusty on my trig sub.
Shouldn't it be
I don't
like?
even remember how it goes.
That's tangent you have.
Yeah, that's
Yeah,
I'm so happy to remember.
Sine is like 1 minus u squared. I think.
Oh.
Oh.
Yeah.
Oh, yeah. Oh, inverse string. That's what you guys want. There's pain.
Oh wait, no, it's different.
Somebody had.
Yeah, I do not remember cosine being in the answer.
Well,
Well, it's gonna be the other way.
Yeah, because you'll change the limits of integration.
You don't need to simplify things.
You just put it in your TI-89. There's no quick way to do this.
I don't even remember how to do it, to be
Me
honest.
neither.
I just like
Eh.
Why and the curves, why children are you.
Ah, stink. Battery's low. Boo hiss.
Is it what you came up with? What is it what you came up with? It's not weird. Because otherwise it's gonna be a big distance.
Natural log of square root of x
Zero to
plus
x.
y squared plus x.
no Leibniz.
Okay, so now you copy and paste that link into check unblock.
No, keep going.
And that gives you the master. I mean,
Someone should just
like-
take a tag membership.
Let's all share one.
Natural log.
You have a Bartleby?
No?
Yeah.
I thought I knew.
Smiley, share us your Bartleby account.
No, you know what's the best? It's when it's numerated and you have to read the transcript.
Yeah.
No.
I do it all the time.
No, if you like put the question in the app, it'll show you the same video on the app.
There's an app.
There's an app.
Mhm.
Oh
Even if you
yeah.
download that. I'm gonna download that right now.
Yeah.
Okay, so that's the answer.
I can't see anything, so.
It's
Doesn't look like they did it.
no, they just showed the answer.
Heck yeah.
Oh, they have a natural log.
Yep.
I have a natural log in my answer.
Oh,
On my TA.
Oh, look at just off the top of my head. Is it the same?
I'm not certain.
Length.
I don't think so.
oh, I guess that makes sense.
Are we gonna have to do that?
No.
B text question.
No.
If we get a
Where's the
no.
thing
Oh
about
yeah.
height?
That's like
Is there really one height? Oh, okay, there is.
That's an
Yeah, no,
answer.
that's okay. No, that makes sense.
Yes, that's what it is. Although,
It's the same thing as
for some reason I have a 2 in my denominator.
Let's screenshot this.
I had 2 in the denominator of the natural log and 2 outside the
Oh.
which is not so nice.
It's the same thing. We're using a coordinate.
Why? All right. So anyway, TI 89 it.
You can do that on the PhD
All right.
Should we keep this human peak, honestly? Just like
Peak music.
no, just like peak human
Where
experience.
is my P? Oh, there it is.
We can't get better than cheap.
Okay, so is everybody good with that? Like, could you get there? Good.
Yes. After you gave me the answer, I understood it.
Smiley, can I ask you to do Wednesday 11 o'clock again?
11 in the morning.
Like right before this class.
That's what you do. Do it a little bit.
How many questions is it?
How many points is it?
No questions.
I don't know. I just said copy paste.
Where?
Last year.
Oh, that's right, Mr. Smiley. I have a video of Ryan Zhang cheating on the math screen. This exact math screen, I think.
Oh no.
Hey, send me the video. How about you send
Preferably
the
zoom
video?
in on the screen.
But like, it's like if even he was cheating, then I think I'm allowed to cheat as well, right?
Yeah.
No.
That's not how that
you
works.
don't-
Get Ryan Zhang
If you
to
tell
tell
people
me
that you don't really get away with it, now do you?
Give me a second, this is very important.
All right.
Next year there's gonna be a kid that comes in. I have a video of Daniel Zhang.
See right here. Here's Brian. He's searching the answer.
No way.
I'm gonna zoom in on the question, but there's Brian.
All right. So what do you say? Talk to your neighbor.
So many cancel out.
Wait, what are the answers?
There's none of infinite.
Yeah.
So it comes from both sides.
So the thing about
So they're going opposite.
like where it is,
Wouldn't it be?
literally doesn't matter. I could put
Infinite
Oh.
points of this.
middle axis and there's
Wait, so what did you say your answer was?
signs
C?
on both
Makes sense
sides.
because all of
Just one side's more
The
infinite
Y
than
is-
the other.
the Y's.
Except
No, they do it.
It's both out.
Why?
Well,
Actually, no, not Alec. No, no.
yeah.
This would.
Oh, why is
this
this
would be
one?
counting
Okay,
numbers?
sorry.
This would be max. This would be real
I
numbers.
created
So Alec
Y
won.
infinite.
Okay.
exclamation.
Correct answer is?
C.
I'm going to say it is
If it's
D.
Why?
I think it's a limit.
Yeah.
Oh, okay.
Okay. The X components cancel out. Okay. And it doesn't matter. It doesn't matter if it's offset. It's infinite. Like it's a mute point. That's what they want you to think. Okay. So the Y component for something out here is gets smaller and smaller. I'm pretty confident that there's a limit that it approaches.
I'll run the integral and see.
Go for it. Okay.
I'll do it at home. I
I'm
don't
just
know.
gonna do it from
Okay.
negative infinity to infinity.
So
Oh, let me use my
look at me. All right. So this is what are we doing here? So this is a crazy. I wrote this down because I never remembered how to reproduce this, and I don't expect you to as well. But the concept is this. So we have a linear charge density of lambda. Okay. And what I'm doing, what am I doing? I don't know.
Okay, so that was just that field thing that we got from yesterday.
Yes, this is from a segment. This is this. Okay. And with I think I'm just factoring junk.
Yeah.
Yeah, I'm doing some crazy math just to get things in the right order. What I want to do is pull L out of here so I can put this is Q over L times 1/2. Nope, times
Times 1/1/2. 1 over 1/2.
1 over 1/2. So this,
You also should cross out the L over 2. But
right, this becomes lambda, okay, and this becomes 2, like the 1 over 1/2 becomes 2.
no, that would be fine. Yeah.
And then At this point, you substitute L or infinity in for L, and that drops this expression to 0. So that takes that to 0. So you have a square root of 1, 1. So that knocks this expression out, and you're just left with this.
And then finite.
Good with that? Okay. So that is an expression for the electric field a certain distance away from a charged rod or wire that's infinitely far away. Yes. I know, that's why you have to do this craziness. Like, I don't know. I don't know my math well enough to like argue, but that was the roadblock I came into, and I was like, how do you do this? And I looked up, like, I would never come up with that.
It's really odd because they're both closed expressions.
It's quite simple.
Just copy somebody else's work.
Put something on the board. Make something up.
So the reason, okay, so when we get to this, when we're talking about a wire that's charged compared to an electron or something like that, that is essentially infinity for from a perspective of an electron. Just like the distance across the Milky Way galaxy, that's infinite for our practical purposes. Like, we're never going to reach there if we had to run it or even travel it in some kind of spaceship. Like, it's 100,000 light years across, so it's infinite, but it's not even close to infinite because there's billions of galaxies. So it's just from a perspective. Okay, so taking infinity isn't, from a math point of view, like, no, it's infinity. Like, from a practical point of view, you just say it's really long, and it works. Okay. All right.
I can think of one number that's close
Hey. Static electricity and the throes of calculus.
Take you over.
Not fun.
Just sits there and eats sandwiches in your room too, huh?
Yeah.
You don't.
Yep. Perpetual eating machine.
Yeah.
Oh, this is field. Oh, this is field. Never mind.
This is field, not electric potential. And it's just dE. It's just a little chunk. Bless you. Tell your neighbor.
Tell your neighbor bless you.
Bless you.
I forgot we were working with fields now.
Better go look at mine.
Correct answer is
C.
I like it. Good at that.
You good, Ross? That one makes sense.
Okay, if it's not coming to you without doing calculus, go ahead and do the calculus or do the setup. You'll find, like, when you do the setup, you'll see why you don't have to do calculus, if that makes sense.
That's just the point.
Good one.
Yeah, I treat this wrong.
That means it's right, actually.
Let's see who's. You
No,
can
okay, so I'm thinking,
It says without integration. That's what.
I'm thinking here, it's the same, C is the same thing as last time, except instead of DQ, it's BQ.
That doesn't make any sense.
Which makes
K is a different thing.
No, K was in the last one.
K wasn't.
Yeah, and so big Q is all DQs added together. So I'm.
Also, it doesn't look as complicated as T. But which
All right, so let's do the calculus.
Actually, you know what?
Okay, so here, this guy creates an electric field doing that. Okay, this guy creates an electric field doing this. So the X components get canceled. Okay, so it's just the Y component we care about. You all right with that? Okay, so I am integrating. Oops. I am integrating the Y components. What do you want to do? You want to do as like 2 pi? You want to do it 2 pi r? Let's do 2 pi. From 0 to 2 pi. Okay. Does everybody see what I'm doing?
Yes.
Okay. So I've got K dq. Maybe let's do. Maybe 2 pi r. I'll do 2 pi r. 2 pi r. So I've got lambda is equal to q over the total length, which is 2 pi r. That should be capital R, sorry. Is everybody okay with that? Okay. And dq is equal to a little dx. Okay. So that's equal to k q over 2 pi r dx over r squared.
Yeah.
R squared plus z squared. That would give me my whole electric field, but I just want the x component of that. Y component of that. Thank you. This angle is the same thing as this angle, so I want the cosine of that. Should be. Thank you. Good catch. And then the cosine of that is going to be adjacent over hypotenuse
And the answer is D.
Everybody okay with that?
Yeah.
Okay, so when we go to integrate this, all this stuff is constant, all this stuff.
Yeah, literally everything is.
And so what I get is this expression dx 2 pi r to 0, this just becomes 2 pi r minus 0. Okay, which takes out the 2 pi r up top. Because these are all equal distance away from this point. That's why you didn't need to do calculus.
Go back a bit to where you're integrating.
I have not integrated. This is just me substituting what r is. I should do this, sorry. I should do cosine theta. There. Okay, this is cosine theta. This is r. This is dq. Sorry.
That's not important.
My bad.
You don't need that.
Okay, good with that? Okay, so the correct answer is D. Dancing dinosaurs. Okay, so here we go. What happens to the electric field when we're very far away?
The look of disappointment.
Correct answer is point charge. Okay,
Oh, yay.
make R 0.
Otherwise, you got
That's almost infinity.
You have infinity over infinity and it's annoying.
Okay.
It would be 0.
Good with that? Okay, what about when Z is 0?
Oh, okay.
Okay.
Get a wheel.
Is everybody good with D?
Yeah.
Okay, it cancels out.
I hate this font. This looks like a CAPTCHA.
What the heck?
Okay, with this, it is. I'm gonna erase this. Is everybody okay with that? It's positively charged. You're graphing the strength of the electric field, not only the strength, but also the direction of the electric field as a function of Z.
None of these are, none of these is.
Neither of
Smiley,
It would still be R.
the master's gonna have us calculate what the maximum is of that, or something like that.
Maybe. Correct answer is. Okay. I'll give you a really strong suggestion. Consider direction.
Yeah.
I'm trying, but it's so hard.
I think we're
I'm really struggling.
Which way's positive on the Z-axis?
Yeah.
Up.
Okay.
Okay. There we go. I can do that.
Yeah, we're going. There's no doubt.
Correct answer is
B.
B by process of elimination. Okay, this is the only one that has. It's the only one that does electric field from this positive is going this way, from positive is going this way. It's going out from positive.
I was really confused how you're supposed to figure out what direction it goes.
Oh, I didn't even notice that.
It's, if it was negative, it would be flipped.
And so C would be the answer.
Correct.
The next slide.
Okay.
Oh,
Dang it.
So,
Yeah, sorry, I tried
when the strength of electric field is 0 in the middle, and at some point it reaches a maximum because far away it's close to 0. Okay, and because they're going in opposite directions, that's why you get this thing going on there.
That's cool because that's where it's.
The maximum before the radius. I hate this.
Oh, is it really?
Yeah.
Oh man.
If the maximum were at the radius, I'd be like, okay, that's cool.
What if it was like a big radius?
You just make it closer here. I mean,
Actually?
no, I mean it's like a big radius just means you'd have to go further out before you reach the maximum.
Yeah, like it's on the z-axis, the particle.
Okay.
So it's just traveling up and
All right. Electric potential
down. It was the same questions. It's just you just put the graph.
at
Oh.
point P.
Oh no.
It's the same thing.
Oh, yes, there's something with there's something with lawn in there.
Hint, electric potential doesn't have direction.
Oh.
What if it does have direction?
Like, go ahead and do this like full on because this is straight up an AP question. Oops. Let's just do Q.
Probably want a poorly blown chocolate. A poorly blown piece of chocolate, sir. Why are you doing over here?
Yeah.
Mr. Smiley, what does little r represent?
Good question.
It's that line.
Dotted line.
The dotted line. Yes. So a lot of times they will use capital R for a fixed radius and capital Q for like the total charge. Is a kind of a theme in the
Now,
variables.
in this case, both radii are fixed.
Yeah.
Right.
Well, that's a different problem.
Wait, Mr. Smiley, call me stupid, but in case you Smiley, how do you?
Mr. Smiley.
But why is it TQ over little r instead of like.
Because it's that distant, this distance from this charge, little piece of charge.
Wow.
No, you're good.
Yeah, you are.
Am I dumb for thinking this is similar to a line? Because all the, what do you call it, horizontal and z direction. Are we going in the z direction?
You're gonna have to do that whole cosine thing again.
Tell me
It's like it all cancels out except for z. But because of the geometry, I don't think it works.
Okay, the y, the x and y components can't be.
I said dq over
Right, or
little, like over d equals q over r.
No.
The angles are the same.
R is fixed.
Yeah. I'm sorry.
What it should be
Try not to say
dq cosine theta.
It's a fun one. Technically. What is dx?
No, there's no direction. Because it's electric potential.
Sorry, yeah, never mind.
It would be the segment line.
Say what?
dx is a little segment around.
Yeah. It's this. dx.
It doesn't make sense when you draw it large enough to be able to see. As it gets smaller and smaller, it makes sense.
Okay.
dx over 2.
So,
This is so wacky.
That would be 0.
okay. Is this a changing or a fixed value? Fixed. Is this a changing or fixed value? Changing or fixed? So all of that goes out of,
And so dx from 0 to 2 pi r, so we just multiply everything by 2 pi r.
yeah. Okay, so that just becomes 2 pi r minus 0.
Yeah.
When you integrate that. And so you take, so this part here, the 2 pi, yeah, so this part here becomes 2 pi r minus 0 times this quantity. 2 pi r's go away, and you're just left with this.
Yeah, it seems.
That is definitely on you. Okay? That's a definite.
I mean, since you don't
Micah.
actually have to do the actual roll for that.
I was gonna say, could we just, I didn't realize that, like the radius is
Yes.
and we're going to just plug in.
Yes. Yep. You could do that. Okay, does everybody see that? Here's what Micah was saying. Here, the radius is this, and we're just adding all these up. Nothing's changing. So the total charge is the same distance away from that point. So it's just K times the total charge divided by the distance.
And this works because it's not directional.
Correct. So it works because it's a scalar and not a vector.
I'm assuming this gets wacky if you move it anywhere on the x or y.
Yeah. Okay. But this, folks, understanding that is really good. You can memorize that for like a charged ring, uniformly charged ring,
Or you can just really rederive it.
or rederive it. But knowing where that comes from, good. Like that. This, yes, definitely. This, like that stuff. Ugh, maybe, but this, absolutely. Okay. Mhm.
Really off topic, but for a first test, is there gonna be like magnetism on it? Cause on
No.
for response, I mean not for multiple choice, cause
No.
kind of random multiple choice tests wanna have like everything, all the.
Well, yeah.
So I won't give you that.
He doesn't just copy and paste it. He selects.
He's definitely
I mean,
copy.
he copies and pastes most of it.
But he copies and
Like
pastes the
certain
question, but he doesn't copy
Right.
and paste the whole test.
Oh.
Right. It's not until the last test can I do that.
Okay.
And that was true last semester too.
Oh. That's good.
Like I couldn't.
This game is for the same problem.
Okay.
Alright, that's good. I don't know.
We'll call that good for today.
Correct.